Hello everyone, today I am with a new problem of IIT JAM 2026. This is a question of quantum mechanics that says consider a normalized superposed state psi equals to C0 phi 0 plus C1 phi 1 where phi 0 and phi 1 are the ground state and fast excited states of a simple harmonic oscillator respectively. C0 and C1 are imaginary superposition coefficients. Which of the following options is correct for the expectation value of x plus ip? There are four options. So, we have to calculate the expectation value of this quantity. Okay. Now, it is given that normalized superposed state psi is C0 phi 0 plus C1 phi 1. Okay. Now we have to calculate x, expectation value of x, plus I, expectation value of p. So at first we are calculating expectation value of x. Now for harmonic oscillator, position operator is given by root over h cut by 2m omega a dragger plus a, where a dragger and a are ladder operators and a dragger is raising operator and a is lowering operator. How this acts on the nth state? A dragger acts on nth state and gives us root over n plus 1 state. That's why it is called raising operator. And when A acts on nth state, it gives root over n minus 1. That's why it is called lowering operator. And momentum operator is given by I root over m h cut omega by 2 a dragger minus a. Okay. This is our position operator and momentum operator. Now the expectation value of x is psi x psi. Now put the value of bra psi, that is C0 star bra phi plus C1 star bra phi 1. Look, here it is told that C0 and C1 are imaginary superposition coefficients. That's why it will be conjugate of the C0 and C1. Okay. Now put the value of x h cut by 2m omega a dragger plus a C0 phi 0 plus C1 phi 1. Now it will give h cut by 2m omega C0 star phi 0 plus C1 star phi 1, and a dragger operates on these two states and a operates on these two states separately. So when a dragger acts on this, it will give C0 phi 1 plus when this acts on this state, it will give C1 root 2 phi 2 plus when A acts on this state, it will give 0. In this, from this formula we can get this, and when A acts on this state, it will give C1 phi 0. Now h cut by 2m omega. This acts on this and gives C0 star C1 plus this state acts on this and gives C1 star C0. Okay, this is our expectation value of momentum operator. Now calculate the expectation value of momentum operator similarly. So it will give psi p psi. Now put the value of p I root over m h cut omega by 2. Brass I will give C0 star phi 0 plus C1 star phi 1. A dagger minus A and psi C0 phi 0 plus C1 phi 1. Okay. Now it will give m h cut omega, this is m, by 2 C0 star phi 0 plus C1 star phi 1, and when A dagger acts on this, it will give C0 phi 1 plus when this acts on this, it will give C1 root 2 phi 2 minus when A acts on this, it will give 0 from this, and when this acts on this, it will give C1 phi 0. Okay. Now m h cut omega by 2, this acts with this and gives minus C0 star C1, and this acts on this and will give plus C1 star C0. Okay, this is our expectation value of momentum operator. Now we have to calculate the value of this term. Okay, so expectation value of x plus I, expectation value of p will give, put the value, root over h cut by 2m omega C0 star C1 plus C1 star C0 plus this I and this I gives us minus 1. So minus, put the value of expectation value of p, m h cut omega by 2 minus C0 star C1 plus C1 star C0. So it will give C0 star C1, that is root over h cut by 2m omega minus plus root over m h cut omega by 2 plus C1 star C0 root over h cut by 2m omega, this is minus root over m h cut omega by 2. Now look, C0 and C1 are imaginary superposition coefficients. So C0 and C1 are purely imaginary coefficients. Now let's consider C0 is IB, C1 is IC. So C0 star will be minus IB and C1 star will be minus IC. Okay. So C0 star C1 C0 star C1 gives us C0 star C1 minus I square BC. So this is BC and C1 star C0 will C1 star C0 will also give us BC. So the value of expectation value of x plus I expectation value of p is BC. This is also BC. So BC take common and h squared by 2m omega plus, look, where we'll put the value BC and BC here, this term will cancel. So it will give 2 into root over h squared by 2m omega. This is the value of the given quantity. So look, this is a real quantity. Here no imaginary number is here. So our correct option will be option B, that is real. That quantity, the result of this quantity will be real. Okay, thank you.